Okay, so let's get going on today's meeting. So before we begin on the on our new look at probability, before we take up exam number 1, I just wanted to introduce step 2, assignment 2 of that social media professional development bonus point opportunity. So a lot of you have taken advantage of step number 1. That's awesome to see. So now we're going to build on that. And assignment number 2 is all about connecting to your community. So now that we have established a professional presence, we can begin to reach out and connect to our community. So you're going to notice that for the first little bit of this social media development, you're not actually going to be tweeting out anything on your own. So I would highly recommend, unless you've read guides on how to engage in academic social media, that you refrain from tweeting out, because we're building this to make sure that you do have a media presence that is beneficial to you when employers look at it, when grad schools look at it. So we're going to be eventually more engaged with the social media network and community that we're becoming a part of. But for right now, we just want to get connected in it. So this week's social media assignment is simply to follow 5 psychologists on Twitter. So this is the beginning of getting into that network. And really, this is a very open-ended one, because who you choose can be completely based upon your interests. So there are a lot of psychologists that are very active on Twitter, posting about their work, posting about their jobs, posting about their research. So find one, do a little Googling, and to find one that you are interested in. So potential sources for where you can find these. One, if you're going to grad school, grad schools are a great place to start. So if you're thinking about, after I graduate from IUSB, I want to go into a grad school, Google graduate programs in your field, in the area that you're interested in, and you might find that Stanford, in the Department of Psychology, has one that you're interested in. And then you can take a look at their faculty here, and you might see Jamil Zaki over here, and you might say, oh, decision science, motivation and emotion, self and identity, perception, psychopathology and risk. Those are things that I might be interested in the future. So he might be a prime candidate for one of the 5 psychologists that you follow. So if they have active social media profiles or presences, sometimes they'll list it on their homepage. Other times it'll just be easy to find them on Google if you just Google them for their Twitter account. And then you just follow them and you start to become part of their particular network. So that's one way to do it. Research, take a look at grad schools that you might want to apply to. Take a look at places if you're thinking, well, I'm just going to graduate and then I'm immediately going to enter the psychology workforce, and you want to stay in South Bend. Take a look at places in South Bend that you might work for, where you might get a job in South Bend, who's looking for a psychologist, and then follow, the people that are working there to get plugged into that community. So another example of somebody that I follow because they're an editor for the Comics Grid, the Journal of Comic Scholarship. And this is one of the journals that I publish with often. And I want to make sure that I'm up on all the latest news, latest deadlines, such as they are currently closed for submissions until the 1st of November. But if you find a journal that you're especially interested in, one that's in your area, usually the editors are people that are big in that area, big in that community. So you can just take a look at those and maybe follow one of the editors. And I follow Ernesto Priego as one of my nodes in my social network. So find 5 that you follow. You can follow more if you like, but let's shoot for a minimum of 5. And then send a screenshot of your follows to Canvas via those Canvas messages. So whenever you follow somebody, you can go to just a listing of your page of who you're following. They'll be on there. Just take a screenshot of that, send it to me. And the due date for this is, it should be, Monday, October 7th at midnight. So once again, you got the whole week to do this. So, plug yourself into the community that you want to be a part of, and let's start building these networks, these connections. Because eventually, and this is one of the reasons why I would caution you against tweeting at the moment. Eventually, we will be asking things of our community. I'll see how it progresses as we go along. But one of the kind of rules, unwritten rules of engagement in social media is that you don't take until you give. So part of building this is going to be us giving back to the community before we go out and say, can you please take this survey? Which is what one member of my community did this morning. And because she has given a lot to the psychology and study of comics, I was more than willing to say, absolutely, I'll take your survey. So we're not going to take yet. We're going to start building this by giving. So first thing we're going to do is we're going to follow those 5 psychologists. Any questions on this step? All right. All right. So, and just one last mention for the exam. If, as I was going through this, you saw a correct answer and it was graded incorrectly on your exam, just drop me a message in Canvas. But please make sure that it was the exact answer, not something that you manually entered, not something that you didn't use the equals function for, not something that was close. Okay, because again, we have to, in statistics, because of the importance of what we're doing, be as exact as we possibly can. All right, on to today's class. So what we're going to be doing today is we're going to continue on with our look at probability. Yep.
So I have a question about the extra credit. What if we already did that for your last class, for your cognitive psych class?
If you already did it through the cognitive psych class, then for the first ones, for the first steps, you can use what you did historically. For the later ones, you'll have to join in. So in terms of setting up an account, don't set up a second account. In terms of following psychologists, I think it would be to your benefit to find another 5, but you can already send me the 5 that you're following. All right, so probability. One of the last pieces we need for inferential statistics. One of the last pieces we need to take psychology from something that can help a sample of individuals identify a treatment that works for a sample of individuals and intelligently expand that to a population of individuals. So once again, without statistics, without the skills that we're building right now, if you were able to find a breakthrough treatment to increase the learning outcomes of 14 children with autism, that was the kids in your class, that was the sample that you were working with, without what we're working on right now, that is where the story would end. That is as much as you could say. And you would not be able to help a single other autistic child in the entire world. Your results, all your effort would be limited to those 14 individuals rather than the population of autistic students that we can help. So I don't know about you, but I don't want to live in a world where psychology is reserved for the wealthy. If this was the case, then psychologists would exist, but we would be employed by the millionaires who could afford to pay our entire salary to work on their 1 or 2 children. I don't want to live in that world. I want to live in a world where we can help everybody, and that's what statistics allows us to do. That's why it's a required course in psychology. So we want to intelligently be able to go from these 14 subjects and intelligently generalize, and that's the key. Intelligently, objectively, without human bias, generalize to see if the treatment that worked for those 14 individuals will work for the entire population. That's the end game. All right, so today we're going to have a very brief recap of the normal curve, and then we're going to take a look at how to use probability and the normal curve, and we're going to use z-scores and learn how to read the normal curve table so that we can answer questions about proportions, about probability. So to recap what we did last time, the normal curve, it's a mathematical theoretical distribution. It's a frequency distribution. It looks like this. It's that classic bell curve where there's a high frequency of scores in the middle range and lower frequency of scores as you go up, lower frequency of scores as you go down. And this is more than just a theoretical distribution. This is a distribution that happens in our universe so very often. And it occurs whenever multiple random factors combine to form a single score. So as we saw last time with this animation, there are multiple pegs that can send these balls into all these different directions. And because their final position is the sum of how many times they went left and how many times they went right, their final position forms a normal distribution where most of the balls end up in the middle and fewer of those balls end up in the extreme high or extremely low scores. So many random factors combining to form a single score is literally basically what happens to every human characteristic that you have. There are very few behaviors that psychologists study where it's not multiple factors that contribute to this single score. So SAT scores, intelligence, as we saw last time, multiple factors. That's why scores are on a normal curve. Height has multiple factors. That's why heights of males and heights of women on a normal curve. And as I mentioned, intelligence has multiple factors. And I'll just reiterate this point one more time. Any of those factors can cause these differences here. So it's very important to keep that in your mind. You see a normal distribution curve, it means multiple factors because our human intuition usually jumps to one factor depending upon our biases, and that has led to abuse of findings such as this gap between the IQ scores for the black and white populations. All right, so that was a recap. So probability in the normal curve. Remember I told you that we were going to use proportions of a frequency distribution in order to think about probabilities. Well, this is the frequency distribution that we're going to use because it's the one that happens over and over and over again. So we're going to see how you can use this frequency distribution to answer questions like what percent of a population scored below 1.25. So if you'll notice, the mean here is 0. The standard deviation on this distribution is actually 1. So this is a z-score normal distribution. So we're going to see why that's important in a little bit, but it allows us to say, all right, if there is a score of 1.25, what percent of the population scored below 1.25, i.e., what is the proportion of the blue area to the entire frequency distribution? We're going to see how to answer questions like that. You can also answer questions such as, what scores bound the middle 50% of your population? So there are a lot of, for example, as an educator, there's a lot of techniques, strategies that will work for the middle group of students. Students that are highly advanced performers don't need these strategies. Students that are lower performers can't take advantage of these strategies. So if I'm implementing something new in a classroom and I want to know who's going to be affected by it, it's going to be the middle 50%. I can use a normal distribution to figure out that's the middle 50%, and those are the z-scores that bound the middle 50%. And you can answer questions, and this was going to be very important for those of you going to grad school, doing your GRE. What score do you need to be in the top 10%? So if you are looking on at your grad schools, they will have things like, oh, we accept, students in the top 10% of GRE scores. We typically accept students in the top 20, top 30%. You can see different grad schools have different cutoffs. If you want to go to a grad school where you need to be in the top 10% on any single measure, what z-score do you need to be in the top 10%? Well, you want to get into that. So we'll find out how to identify that as the top 10%, and then how to look up the score that you need which would be a z-score of 1.25. All right, so all of this is going to be done by using the unit normal distribution table. So if you haven't already, I would highly recommend, as we're going through this, follow along in your textbook. So if you got Canvas open, if you don't have Canvas open, I would suggest logging in. Get to your textbook so that you know exactly where to find these tables. Where you find it, if you go to the table of contents, it's in the appendices. So you go to the appendix, and it is appendix A1. Right? So you want to go there to the appendix and tables. And just to kind of show you the importance of this normal distribution, it's the first one that you encounter. It's A1, it's appendix table A1 there. So make sure you know how to find that. You will need it for your homework. And I, again, highly recommend just follow along with that in today's class. All right, so how do we use this normal distribution table to look up percentages? So what this normal distribution table does is it has 3 columns. They print them up in a single page. There's 6 columns in a single page, but you'll notice that there are 2 sections, separate sections each. So each major section has a z-score, and then it has the percentage in the distribution that goes from the mean, that's the center of the distribution, to that z-score. And then the next column is the percentage from that z-score to infinity and beyond, the percentage in the tail. So the biggest challenge in using the z-score distribution table is knowing which of those 2 columns here you need to be looking at. Which of those 2 columns there do you need to get your percentages from? So, for example, if we have a z-score of 0.3, so we have a z-score that's above the mean, we know that immediately. If we have a z-score of 0.3, that first column there, that second column there, the percentage in the tail, that gives you that percentage. So there is your z-score of 0.3, and the blue area here is the part that's above that z-score. It's the part in the tail. So the larger part of the distribution is the body. The smaller part of the distribution is the tail. So wherever you split it, whatever smaller is the tail, whatever is larger is the body. So if we wanted to know what is the proportion above a z-score of 0.3, we want to know that blue area. We would look that up in the table and we would say, oh, that is 38% of our distribution. On the other hand, if we wanted to know what is the percentage of scores that are above the average, above the mean, but below that particular z-score, aka we want to know that area right there, then we have to realize that, okay, that is above the mean and below our z-score of 0.3. That is this column right here. And the columns have these very nice pictures that kind of show you, yep, that matches the type that I'm looking for. So we have our percentage from our mean score to our z-score. So this little sliver of this entire distribution is 11.79% of that distribution. So those are 2 out of the 3 major types of ways that you'll use this distribution. The last one is when you're interested in the percentage in the body of the distribution. So let's say that we were interested in the percentage that is below a z-score of 0.3. So one thing that you'll notice in this z-score distribution is that there are no negative scores, and there is no column from that says below a particular z-score. The reason for that is just to save on space, because those 2 are not necessary in order to be able to use the table. The negative scores are not necessary because the unit normal distribution is symmetrical, so we don't need the negative scores because they're the same as the positive scores. And we don't need a separate column for below a mean the amount, sorry, below a z-score, the amount in the body of a z-score, because there's a couple of different ways to figure this out. You can use whichever way is most comfortable for you if you figure out a different way. I'm just going to show you one way that will work. So the way that you can think about this is if you have a unit normal distribution, you can split this into two parts. So you have the lower half right there, and then you have from the mean to your z-score. You have the percent from your mean to your z-score. So when you split up this blue area here into the lower half and the percent from the mean to the z-score, then it makes this a little bit more straightforward. We can look up on the table what is the percent from the mean to the z-score. That's 11.79, so we have this part of the part we're interested in. And then to that, we just need to add the lower half. The lower half is 50%. So we just add 50% to that, and we see that that entire blue area is 61.79%. So we don't need that third column. It's just a little straightforward logic and math, and we can discover that that is 61.79% of the distribution. That's not the only way to do it. If you find another way, feel free to use it, but that is one way to get to that, that proportion. All right, any questions on that? So we'll go through a few more examples just to show you how to, a couple more times how to do this. So if we have a z-score of 1.0, once again, we might be interested in the proportion of people above that z-score. That would be the tail area right there. And one thing that I will heavily suggest, when you're doing these questions, draw this out, kind of like I drew it out right here. Draw your distribution out, put it down on the page, what area you're interested in, because you will be amazed at how easy it is to forget when you're juggling 5, 6 pieces of information in a question. You'll be amazed how easy it is to forget which column you should be looking in. This is by far the biggest mistake that I see students make. They'll get everything correct, and then in the final analysis, they'll look in the wrong column and end up with the incorrect answer. We're psychologists. We need to get the correct answer. So we want the proportion in the tail. Which one of these looks like the picture we drew? Well, it's this column right there. So we find a number in that column, and we find that that tail, that blue area, is 15.87% of the entire distribution. Same thing if we're interested in the area from the mean to a particular z-score. If the question is asking how many people scored above the mean but below that z-score, color in that area, draw your distribution, color it in, and then make sure that you're looking at the right column. Because you will need to scan down this column here to find the correct z-score, and then you gotta, if you didn't write it down, you got a 50-50 chance if you forgot which one it is. And I've seen it happen very, very often. Don't leave it to chance, draw it, take a look, say, okay, yep, that's the column right there, and we have our, we find out that that's 34.13%. And then finally, sometimes you're interested in scores below, you're interested in more than half of the distribution. So in this case, how many people scored below? So we have this entire big area here. Again, this is the third type of thing you might be asked. Split it into two. We got the lower half. We got from the mean to the z-score. So we know we got to look at this column for part of that information, so 34.13. And then to that, we add the percentage in the lower half, 50%. And we find out that that is 84.12%. The blue area, 84.2%, 12% of the entire distribution. All right, so one last thing that I'll point out, and this is just to make the entire analysis complete. If you ever asked to look at percentages for a z-score of 0, that should trigger a little alarm in your head, because a z-score of 0 is a z-score that is right at the mean. So just so that it's not confusing, if you're interested in the proportion in the tail, that's going to be 50%, because a z-score right at the mean at 0 leaves you 50% in one area. If you're looking for the percentage between the mean and your z-score, well, there's nothing between your mean and the z-score, so that would be 0. So percentage in the tail, if you're going how much is above that, will also be 50% as well. So don't let that one throw you off. It's just a special case. And again, if you're looking for the percentage between the mean and a z-score, that percentage is 0 when your z-score is 0, because that's right at the mean. All right, any questions on that? All right. So let's put this into practice now. Let's see how we can do some additional things with this information. And that is to use this table to answer questions like what percent do you need, or what score do you need? So there's only 2 types of questions that you can really ask where you're going to be going to the table. One of those is, what percentage do I need in order to attain a certain score? And the other ones are, what score do I need in order to attain a certain percentage? So we're going to take a look at those 2 to wrap up today. So we're going to start off with the one where you're starting with a raw score and you're trying to get to a percent. So there's a few steps that we're going to do in order to answer this question. First step, we want to convert your raw score to a z-score. In order to use the table, you need a z-score at some point. Sometimes it'll be given, sometimes you'll need to calculate it, sometimes you'll need to look it up, but you always need a z-score in order to access the table, so that's going to be a given. So if you're not using a z-score, if you're not looking at the table, something has gone horribly wrong. So if we're starting with a raw score, first thing we do is we convert that raw score into a z-score. Step number 2, this is not in your book, this is my additional tip. Draw your normal curve. Draw this. Color in the area that you're interested in. You will be amazed how easy you forget what part you were looking for and make that mistake right at the end. After doing all the hard, heavy lifting, you just kind of drop it right at the door. Don't be that person. Draw your normal curve. And don't be that person that thinks they don't need to draw their normal curve. We're all humans. We can keep about 7 pieces of information juggling in our head, and you'll find out that it takes about 8 or 9 pieces of information to do these questions. So draw it, unload it from your brain, get it down on paper. So draw your normal curve. This one's in your book. Make a rough estimate, and then we look up the percentage associated with the z-score that we calculated in step 1 on the normal curve table. And then we check our answer against step 3. So that look up the percentage, that's where we get our answer. So let's take a look at this in practice. So back to SATs. So each section of the SAT has a mean of 500 and a standard deviation of 100. So for a population mean of 500 and a standard deviation of 100, what percentile rank are you if you scored a 333? So percentile rank is how many people scored as good as you or worse. So how many people did you beat? How much better are you or what percentage of the population are you, did you score higher than? That's what a percentile rank means. Incidentally, in your homework, if you ever come across a term like that and you don't know what it means, it's probably in your textbook. It's definitely online. Just feel free to Google it and say, oh, that's what a percentile rank is, if you're not sure. All right, so step number 1, convert your raw score into a z-score. So you'll notice z-scores are not leaving us. We still need our z-scores. That's the formula for a z-score. Your raw score minus the mean divided by the standard deviation. There's your raw score, there's your mean, there's your standard deviation. We pop that all in and we get a z-score of minus 1.67. So immediately we know this score is below the mean. 333 is below a mean of 500. Importantly though, we're done with step one. We have converted our score into a raw score. Step number two, draw your normal curve. Draw the area that you're interested in. All right, so this is an Excel sheet that I made. It draws it exactly. Okay, I don't use this Excel sheet other than to make these pretty pictures for these classes. This is what it looks like when I'm actually trying to answer these questions. Just draw it. All right, so there's your mean of 0. You have a z-score, whoops. You have a z-score of minus 1.6. That is somewhere over here. You don't even need to know where it is. You just know that it's somewhere over here. We're just going for the category of things that we're interested in. That is the percentage of people below you. That's what we're looking for. Draw your normal curve. So there it is right there. And yeah, please make sure that you do that step. So we are interested in the percent below that particular z-score. We're going to reference this later on. Number 3, make your rough estimate. So this is in the book. Sometimes this gets a little bit confusing. So I thought I would go through with it here. So in your book, when you're saying make a rough estimate, what they're talking about is this graph right here. So it's figure 4.2. And this is the kind of graph that isn't used very much, but used to be used a lot before we had access to statistical packages, where you would kind of memorize major sections of the frequency distribution. So what this graph tells you is that between a z-score of 0 and 1, you have 34% of your distribution. Between a z-score of 1 and 2, you have 14% of your distribution. And above a z-score of 2 is the remaining 2%. So the first thing you want to do is ignore that plus 3 and ignore the minus 3. I don't know why they're there. They're just confusing. They add no information. You can use some liquid paper or whiteout and just get rid of them because they're useless. What it's saying is that above a z-score of 2, that's 2% of your distribution. Exact same on the negative side. Between 0 and 1, 34%. Sorry, minus 1, 34%. Between minus 1 and minus 2, that's 14%. Between minus 2, I almost made the mistake. Between minus 2 all the way down, that's your final 2%. So what you want to do to make this rough estimate is find your z-score on this distribution. So we have a z-score of minus 1.67. That is right about there. All right, it's below minus 1, but it's bigger than minus 2. Right about there is where our z-score that we're interested in resides. So then what do? What does this tell us? Well, it tells us something about the range of our final answer. And what it tells us is that our final answer is definitely going to be bigger than 2%. Because that area there is 2%. So we're looking for an answer that is bigger than 2%. But our final answer, is definitely going to be less than this entire area, 14 plus 2%. So this estimation here tells us that our final answer, our final percentage, should be greater than 2%, but less than 14 plus 2%, which is 16. So that's all that that estimation does. It just gives you a range. So that if your final answer is outside of that range, you know you messed up and you got to go back and do it again. So that's how you use this graph here, this figure, to make your rough estimate. Find your z-score and then find what it should be above and find what it should be below, and that'll give you the range. Sometimes you'll only get one. So if you have a z-score of minus 2.5, all we know is it should be less than 2%. Any other score, you can kind of get a range. So use that to make your rough estimate. All right, so make a rough estimate. Next, so we have our rough estimate. Next thing, now we're finally ready to go to the table. So notice we got two backup plans to make sure that we get the correct answer. So we go to our table And the first thing we do is we scan until we find the z-score that we're looking for. Remember that you're not going to find negative z-scores because this is symmetrical. So don't get thrown off by that. Just go to the positive z-scores, knowing that it's just the region that you're looking for. And then the last move is which of these columns is the one to go with? So once again, we go to our drawing here and we say which of these looks like the drawing that we made, and it's this column right here. And we also go to our estimate. It should be between 2 to 16%. And we look up in this column the final answer, and notice it is between 2 and 16%, right? If we looked up this one wrong, it's not between 2 and 16. So again, 2 backup checks to make sure that we go to the correct column. We finally check our answer against our estimation, and we see that yes, we did estimate it correctly. It fits within that range, and that is our final answer. If you scored a 333 on your SATs, you scored in the 4.75th percentile, which means that 95% of the population scored better than you, which means that you go back and take your SATs again. All right, any questions on that? All right, so we're going to go through one more of these, but now we're going in the reverse, and then that will be the end of what I wanted to cover for today. A little bit of a squeeze, but bear with me. Just want to make sure that we see this a few times. So that was starting with a raw score. You scored 333. What's your percent? The other thing you can do is start with a percentage and then ask, what's your raw score? So these have different steps. So we once again go through 5 steps. Once again, draw your normal curve. That's my value added portion to all this. Draw it out. It is immensely helpful. Number 2, make your rough estimate. Number 3, look up your z-score. Now you're looking up the z-score associated with that percentage on your normal curve. Number 4, check your answer against step number 2. And then number 5, convert your z-score into your final answer into your raw score. So let's take a look at what this means. Sticking with the SATs, let's say that you were shooting for the moon and you wanted to score in the top 1%. Well, what score do you need to get into the top 1%? For a mean of 500 and a standard deviation of 100, what score do you need to get into the top 1% of the population? First thing you want to do, draw your normal curve. So that's what it looks like. And again, it doesn't have to be exact. Drawing a normal curve will take you very, very little time. There's your normal curve. I don't know, let's say that's your top percent, top 1%. What is that z-score? That's what we're looking for. This will keep you from making an error on that when you're looking up that table. So we draw our normal curve. Next thing, make your, whoops, there it is. Next thing, make your rough estimate. So we go back to figure 4.2. And we identify where the top percent is. So the top percent would be right about there. Right? Again, ignore that plus 3. I don't know what it's doing there. This is the top percent. This is the top 2%. This is, let's say, the top percent. So once we identify that as the top percent, what that allows us to do is it allows us to figure out that our z-score, whatever score this is, we don't know what it is yet, but we definitely know it's going to be bigger than 2. So if our answer from the normal table is not bigger than 2, and we know something has gone horribly wrong, we got to go back to the beginning. So that's our rough estimate. We're looking for a z-score that is greater than 2, because 2% and above is a z-score of 2, so we have to go up higher to go to 1% and above in that distribution. All right, next step. Now that we have our rough estimate, we look up our z-score that's associated with that percentage in the normal curve table. So once again now we look at the columns here, but we look for the percentage right? Because we want to look up the z-score, we have the percent. So we got to look in one of these columns. Which column do you look in? Can you remember which one of these you want? Probably not, unless you drew it. So take a look at what you drew and say, what does this, which column does it look like? Well, it doesn't look like this column. It does look like this column. It does look like that picture right there. So we'll scroll down, scan down this column until we find 1% or as close as we can get to 1%. You're not always going to find the exact percentage you're looking for in the table. So 0.99 is the closest answer we have to 1%. So that is the z-score that we're going to look up. So first we know we're in the right column from our picture. We double check what z-score we're looking for. We're looking for a z-score that's greater than 2. So when we find our percentage in the tail, we scroll to the side, look up that z-score. Z-score is 2.33. We know we're in the right column. Our estimate said find a z-score that's greater than 2. Sure enough, 2.33, greater than 2, gives us confidence that we've done this correctly. We've looked up the right column, we're in the right area. Last thing we got to do is we got to take that z-score and actually convert it into a raw score, in this case an SAT score. So now that we got the right z-score, we go back to the formula we've been using so far. Raw score equals the mean plus standard deviation times the z-score. The mean is 500. Standard deviation is 100. Z-score we just found, 2.33. And we get the answer that if you want to end up in the top 1% in a SAT section, you need to score 733. And this score right there, that'll put you in that top 1%, is 733. All right, so that was an action-packed class. Does anybody have any questions on using the z-score distribution tables in order to answer those questions? All right, so I highly recommend when you're going through your homework, when you're going through your notes, first thing you want to identify, are you starting with a raw score and trying to figure out a percentage, because that has a certain 5-step procedure, or are you starting with a percentage and trying to get to a raw score that has a different 5-step procedure? So have those 5-step slides available, just kind of guide how you're doing it. And it's not mentioned in the textbook, but I will mention it once again. And if you think I'm doing this because I've seen countless students make that error and fumble the ball at the 1-yard line, you are correct. Draw your distribution. Please draw it out and then refer to it. It'll help you immensely not to make that incorrect answer. All right, so now you are set. You are ready to go for homework assignment, Chapter 4, Part 1. So that is due tomorrow by midnight. And just again, a reminder, my stat lab pretest points are always there available. Because the pretest may get more challenging now as we continue going on into the higher order statistics stuff. And just one last thing, I will calculate your projected final grade based on everything that has been done so far. So I will enter the grades for all the assignments, calculate the pretest, correct those pretests, put up the post-test grades, all of that I'll calculate it so you know exactly kind of where you stand right now. And just know that if you're doing great, awesome, continue on that path. If you're not doing as well as you were hoping, figure out what's going on, figure out the changes that need to be made, but also know that there is built-in forgiveness. So if you really struggle on exam number 1, it's not going to destroy your grade, but we need to take care of it right now. All right, other than that, we are done.